Alexander, tienes tu micrófono apagado.
Marco, sugiero que leas entonces tu presentación. ¿Alguien sabe cómo cambiar al sonido del video? A ver, host P. ¿No saben cómo cambiarlo? Bueno.
Sí, con gusto.
Creo que ya hay que empezar.
Si no escuchan el audio. Sí.
Entonces, por favor, empezamos. Please, okay, let's start. Please now we'll have 4 presentations. This will be the first one of the 4. You will see the title. Each presenter will have 20 minutes for the presentation and a couple of minutes for questions, or you can leave more time for questions. In total, we have 100 minutes for presentations, and please keep on time because the system will just close the session exactly at 6. Now, please turn off your cameras, whoever is not going to present. Let's start. Please, Marco.
Yes, thank you. Okay. Well, sorry. Okay. So, hello, everybody. I will present you the following work. Does supervised learning of sentence candidates produce the best extractive summaries? This work was developed in SIG-IPN. Okay, our main research problem is to extract a summary from a big document. The idea of this work is to obtain the summary automatically, and in this sense, there is 2 ways to do it. The first one is extracting the main sentence of the document, and the second one is paraphrasing the main ideas. In this work, we are looking to extract the main sentence. So we're using multi-document as a corpus to obtain extractive summaries using supervised learning algorithms. In this work, our research problem is looking to answer 3 interesting questions. The first one is if there is a supervised algorithm capable to learning characteristics of the sentence in order to classify as a candidate or not for a summary. The second one is in which way the classifier performance is affected when a classifier is trained with a certain corpus and then tested with another one. And finally, we are looking to answer if the classifier performance is related in somehow with the summary quality. The motivation for this work is that there is some works that is looking to automatically obtain the summaries. And the main part of this work is in the supervised approach. However, in these works, they only focus in the performance of the classifiers, but they don't consider the quality of the summary that these classifiers obtain. So in this work, we are working to study the relationship between the summary quality and the classifier performance. So we start with a pre-trained embeddings, and we're using 80% for the training and the 20% remaining for testing. We also use the 5-fold cross-validation in the training phase, and we also use the oversampling technique to handle the unbalanced data. Then we use the cross-validation methods, and we applied 5 different classifiers. The first one is Gaussian naive Bayes. The second one, Bernoulli naive Bayes. And then we use 3 kinds of multi-layer perceptrons. The first one with the hyperbolic tangent, the second one with logistic sigmoid, and finally with a multi-layer perceptron with a rectified linear units. These networks have 4 layers with 100, 50, 20, and 10 neurons respectively. For the classifiers, we use as a performance measures the recall, the precision, the accuracy, and the F1 scores. And these measures tell us the performance of the classifiers for each class. On the other hand, we use Roche and measure to evaluate the quality of summaries. In following, I will show you 2 tables that show the performance of our 5 classifiers, and we compare the quality of the learning versus the quality of the summarizing. Let's see our results. In this table, first, we are presenting our results with unbalanced data. As you can see here, the left, you can see the summarized quality. So we have the Rouge 1, Rouge 2, and F1 score. In this case, the second classifier is that obtains the best summary quality. However, in the left side, we can see the classifier performance in the phases of training, validation, and testing. In this case, the best performance in training was OMP ReLU. So you can see here that in the left side, the classifier performance does not match with the summary quality. This is very interesting for us. As a second experiment, we're showing the same, a very similar table, but with balanced data using oversampling. As you can see here, in the right side of the table, the summary quality is the best for the second classifier. But one more time, in the classifier performance, is the OMP ReLU, who give us the best classifier performance. So let's discuss our results. We can notice in the tables that the relation between the classifier performance and summary quality is not clear. And maybe this is because the classifiers work with sentence, while the quality of the summaries is evaluated by groups of words. So this maybe is the reason why this is 2 different tasks, and it does not match. And it is because that we are measuring different things. With respect to the second research question, we're working using the training classifier in Duke 2001 to solve the extractive summary task. And it's important to notice that the sentence must be labeled in order to apply the supervised approach. So this is a very important step in order to obtain training classifiers. And this methodology was proposed in a previous work. Finally, as a conclusions, the uncorrelated results between classifier performance and summary quality maybe suggest us to evaluate the experiments with supervised approach using n-grams instead of sentence embeddings. So we are planning to do this as a future work. We believe that using universal sentence encoder as an input to the classifiers could be another interesting direction for future research. And finally, an additional research effort should be directed toward proposing another evaluation metric besides the Roche metric. We expect in the future to construct this kind of metric in order, ideally, to obtain a match between the performance in the training with the quality of to generate summaries. This is everything. Thank you for your attention. And now I'm ready for your questions. Thank you.
Thank you, Marco. While waiting for more questions in the chat, please, if you have any questions, please ask them in the chat. The chat icon is when you hover your mouse near the bottom of the screen. So meanwhile, I have a couple of questions. One, if the lack of relationship that you observed is because of the context. My understanding is that you classify the sentences out of context. If you take into account the context, would the results, I don't say improve, but would they be more expected?
Okay, yes, thank you.
Well, it was a question.
Sorry. Okay, just consider the context of the sentence. Maybe we can see a better relation between the training and classification phase with the quality of the summary.
Thank you. And another question. Let's see if in the chat anybody wants to ask questions, or maybe from the social networks, the host will copy the messages from there. Meanwhile, I have another question. On the slide 12, you said the sentences must be labeled manually. I did not quite understand what kind of labels, because you already have the extracted summaries. Or no, I know you have abstractive summaries, and you have to convert abstractive into extractive. Is it so?
Well, the idea is that we have the corpus, and we decide to label each sentence of the corpus was labeled as a part of the summary or not part.
But yes, but you have in the annotations of the corpus, you have abstractive summaries or you have extractive summaries?
Extractive.
Then they are already labeled. Then you only need to see which sentences appear in the provided abstract and find them in the text. It's automatic, no?
Oh, I see. Okay.
Yeah.
Okay, I will check.
Yeah, please check, because then it's completely automatic. Yeah. Okay. Let's see if anybody wants to ask more questions? Hamed, Sarah, Christian, Daniel, Brian, why so silent? Okay, looks like so far no more questions. So thank you very much for your talk. Let's see how it works. I will show my screen. Okay, so I will show my screen now. Let's see how it works. Moment. Trend. Okay, and share. Okay, now I expect you see the diploma that we will send you for this presentation. The Mexican Society for Artificial Intelligence, MIA, awards this certificate to the authors of this paper, to Sandra, Iram, Marco, and Carlos, for presentation. Does supervised learning of sentence candidates produce the best extractive summaries at MICAI 2020? Thank you. Let's see how to stop sharing. Stop sharing.
Thank you.
Okay.
Thank you.
Thank you. Now in, okay. Actually, I think we should start on exact time each presentation. If you want to say, Iram, I have no idea how to do it. Moment, Iram wants to present something. Security. I have no idea how to do it. Enable lock meeting. Okay, anybody knows how to give permission to Iram to present? Okay, done. Great. Well, Iram, I think you are the next presenter, right? Yes, but Iram, let's wait some 5 minutes. Meanwhile, you can tell us something interesting. You can tell us something about the previous presentation, or tell us more about your keynote. I think that would be the best option. So please tell us something interesting during 5 minutes, and then we can start your presentation.
Well, I would like to have your impressions on this talk, because I think I have no questions from the team. So I would like to hear your opinions. Like you said before, there is Brian, Christian,
Ahmed, Sarah, Felix, Daniel.
Yeah, so please.
Okay, in your keynote, you spoke about bias in such social applications, like predicting that all Black people are criminals.
Yeah.
So could you comment more about it? Whether it is a technical issue, or is it a social issue, or is it just logical, logic contradicting our ethics?
Yes, maybe it's something like that. Like, for example, if I ask you, someone from Mexico City, if you have someone from Ecatepec and someone from Satélite, which one would you think that commit forfeit or robbed a car, for example? Well, I think most of us would say the Ecatepec, the one from Ecatepec was the bad one. And maybe no, maybe we are falling into an exception. However, yes, there are some, sadly, some generalities that may skew the algorithm's output.
Look, my feeling is that there is no real technological solution to this. My feeling is that it's our ethics. That the problem is that our ethical beliefs differ from real logical implications. Kind of, if there is too few, too little food in a city, why not kill half of people and others would live better? There are very many quite logical implications which contradict our ethical beliefs. Sometimes we say, okay, this is logical, but we don't do it. We don't kill people of different religion. Why not? Why not? If we kill all them, then we will live well. Okay, we know why not, but it's
Maybe
not
some
just
religions
simple.
actually do it.
Maybe, but we
Maybe.
consider it not good to say it. Yet another
Yes.
ethical contradiction to logic. So yes, we know why. I think in several minutes we would not speak about why ethics exists. But I think the key point is that here, it's not that truth is bad, not that our algorithms don't see the truth. It's that truth contradicts our ethics. And then the solution is ethical, like in all other ethical solutions in law, in prohibiting us to act in a logical way. Same thing as with artificial intelligence weapons. They can kill quite good, but the law prohibits or should prohibit them to do it.
That's why I presented just afterwards the problem of the police department, because actually the algorithm was not wrong. Even it proved right when it identified the veterans that had some sort of dark past. Then the problem is that they didn't accept it.
What can we do from artificial intelligence community? What can we do for improvement in this situation? Is okay.
That's a tough question because it depends on what the society is looking for. I mean, maybe we try to just produce an algorithm and leave this responsibility to the others. Because I say my algorithm is 99% accurate. So I don't know, it's your data, you give me your data and I will do whatever I can with it. But maybe we should involve a little bit more with the source of the data, because usually we take a task for granted and we assume those who made it were right when they built it. But it's, as we called it, like gold truth, and we do not question it usually.
Probably we can model our ethics instead of just classifying, model our ethics as part of artificial intelligence. And the second thing we can do is to inform the lawmakers, inform about these problems. I think we are on time to start the next presentation. You will have 20 minutes for your talk and 5 minutes, say, for questions. Please, let's start. No, your microphone. Your microphone is off.
Sorry, I'm beginning to share my screen.
Moment. I see a question from Hamed. Dr. Aram, thank you for your great lecture. Don't you think that artificial intelligence needs to focus more on fuzzy logic? Because in the real world problems, 1 is equal to 1 is not true, but in the mathematical system, we use 1 is equal to 1 is true. Do you want to comment now about this, or you want to start your presentation? Because this is about your keynote. If you want to comment, okay, you choose. Your microphone is off.
Yes. Well, maybe I just can comment briefly on this, and that's why representations that are not completely symbolic are suitable for this kind of problems, or distributed representations that are not atomic symbols. So yes, the answer is in those kind of representations, and maybe that's why vector representations such as word2vec or glob or other similar ones are having so much success, because the output is not yes or no, and maybe similar to fuzzy logic, however, with more dimensions. Okay, so I'll begin projecting this talk. Its name is Irony Detection Using Emotion Cues, and the presenter is Omar Cambina. At the end, I will answer your questions.
Hello, everyone. I'm going to present this work entitled Irony Detection Using Emotion Cues. First, I will give a brief introduction. Then our proposal will be explained. After that, the corpora use will be described. Next, the classification scheme we use will be shown. Then I'm going to describe the experiments and obtained results. And finally, I show the conclusions and future work. To start with, let's talk about irony. Irony is the use of words to express something different and opposite to the literal sense. Some important characteristics are that irony is transversal to the pronunciation, lexical choice, the syntactic and semantic structure, and it is considered similar to sarcasm, but used with no bad intention of mockery. People often use irony to express their opinions. That is why it's important for social network analysis to identify irony in order to avoid misinterpretation of phrases. Irony detection uses a set of characteristics and techniques to decide whether a text is ironic. There are some works in which lexical and syntactic features have been used for irony detection, but effective information involving text have also been considered for this task. Considering the role of effective information in irony detection, we propose to use 6 different emotion tags. These emotion tags are love, joy, surprise, sadness, anger, and fear, and their intensities ranging from none to very high for irony detection in text. These emotion tags are obtained from a pre-trained model. With this information, we want to identify irony in different corpora with unrelated topics in regional variants of Spanish. This task is called cross-variety irony detection. I'm going to talk about the corpora we use for our experiment. There is a challenge called IroSVA challenge that aims at investigating whether a short message written in Spanish language is ironic or not with respect to given context. This challenge provides 3 corpora, each one of distinct Spanish variants from Spain, Mexico, and Cuba. Each corpus was manually labeled and includes 1,600 examples of non-ironic text and 800 ironic texts. In order to have a balanced training dataset, 800 non-ironic texts were randomly discarded. For our classification scheme, preprocessing was performed in the 3 corpora. We fixed CRLF lines and tweets running several lines. And also, we removed numbers and multi-word name. The preprocessed text was converted to one hot, that is word space model. And finally, the word space model was converted to embeddings using fast test embeddings from the Spanish billion word corpus. At the end, we have more than 855,000 vectors, and each vector with 300 dimensions. We use a random forest classifier that was trained on a tenfold stratified cross-validation scheme for each language variants separately. And as features, we use the 300 dimension vectors for each language along with the corresponding topic and removing topic information. In the first experiment, we trained the model with a language variant and tested with the same language variant. I mean, we trained with Spanish variant and then tested with the same variant, Mexican variant, and tested with the same Mexican variant. As we can see in the table, results are similar between language variants, around 80% of accuracy. From these results, it is not possible to conclude if the use of topics could be of general benefit for this task, considering that for the next experiment, topic information will be removed. For the second experiment, we built 3 new corpora by combining 2 language varieties in order to observe the capabilities of generalizing irony characterization from only one language variant versus a different one, as well as 2 amalgamated language varieties against a different one. The new corpora were named ES-MX, which combine the ES Spanish and MX Mexican corpora, ES-CU, that is Spanish and Cuban variety, and MX-CU, Mexican and Cuban. In the table, we show the accuracy of all possible combinations. As we can see, the higher values were obtained when a subset have been already seen in the training set. For instance, in the 3rd row and the 1st column. But more interesting values can be observed. For instance, training with Cuban variant obtained better results than Mexican when tested in the Spanish variant. For a single variant training tested on a combined corpora, the best result was obtained by Spanish with Mexican Cuban, MXCU. And finally, a combined variant training tested on a single variant, the best result was obtained with MXCU and ES, that is Mexican Cuban, tested on a Spanish variant. In the 3rd experiment, we use a different set of features. For this experiment, we use 6 emotions and 5 levels of intensities. As an example, in this table, we can see the emotion tuple obtained by the pre-trained model in 3 different tweets. The order of the emotions are love, joy, surprise, anger, sadness, and fear. And the intensity level are N for none, BL for very low, L for low, H for high, and BH for very high. For instance, in the first tweet, we have N for love, joy, and surprise. The intensity is very high for anger and low for sadness and fear. Using this information, we obtained the following results shown in the table. As can be seen, results did not have high accuracy when it's compared with embeddings, the previous experiment. But interesting when evaluating the Cuban variant, both training with the Spanish ES or MX Mexican results are higher than their embedding counterpart. In overall, results using emotion levels only are 1.91% below their embedding counterpart for single to single corpora, which is interesting considering that we have this important reduction from 300 features, which is the vector dimension, to only 6 features. In this table, we show a general comparison of accuracies using embeddings or emotions as features. As can be seen, cross-variety irony detection is performed better when using embeddings as features in average. However, difference found is relatively small, suggesting that emotion features could be used to improve or aid sentiment-related tasks, such irony detection. An extra experiment was performed, this time using emotions and embeddings altogether, but no significant increase in the result was obtained. In the last experiment, we compare our result with other works. It is important to mention that only single training testing experiments were available from this work, so it was not possible to compare the cross-variety results. From the table, we can see that for the ES variant, the Spanish variant, our system obtained better results. But in average, both LDSE and word-to-vec system presented better results. As a conclusion, we can see that a relatively simple model was proposed to classify tweets as ironic or not ironic for 3 different language varieties. Word embeddings and emotion levels were used as features in the training model. The learning features allow the model to identify irony in tweets from unseen language variants. It is very interesting that the model had a similar performance when using embeddings and using emotion levels, and for some variance pairs, the performance was improved. As a feature work, we plan to include information on the context to help our classifier. Thank you very much.
Well, yes, I think it's finished. If you have some questions.
Okay, we have some questions in chat. Let me read the questions. Antonio asks, how do you represent the documents? Did you use max average or padding for word embedding vectors?
No.
And there are more questions.
Oh, okay. Do you want me to answer one by one or ask all of them?
I think one by one, otherwise
Okay,
we will forget which one.
Yeah, actually, yes. Well, no word embeddings at all. It's just a word space model, which is a one hot representation. So for each tweet, it was just a long vector with zeros and ones, where if the word was present, then a one was put into it, if not a zero.
Next question. Why did you use random forest? Did you test it another? Have you tested another algorithm?
Yes, we tested several algorithms, and this one was the best, had the best performance for these features. We think that for sure, with other features, we could achieve better performance with other classifiers. For this one, it was the best one, and yes, we tried others, like support vector machines and MICAI bias classifications.
Okay, next. Did you consider the negation in your work? Do you think that negation could be relevant in this field?
Well, yes, more for the part of emotion classification, because if you say something that might be very happy, and then you say, I was not happy at all, you have to consider negation in order to tag that as sad and not as happy. So yes, it would be relevant, and no, we didn't use it for this work. We aim to be like the simplest, as simple as possible, so we didn't use a lot of resources for this work.
Thank you. Delia Raso Hernandez Farias asks, which resource did you use for determining the presence of emotions? Did you analyze the difference in terms of emotions for each Spanish variant?
We used a tagger of emotions that we developed that actually gives the results of emotions in a 6-dimension vector with 4 different levels. This was presented in a different paper. I am writing in the chat the reference. This is called Predicting Emotional Reactions to News Articles in Social Networks, the Journal of Computer Speech and Language. There we have more details on this emotion tagger. Maybe the important part here is that we were able to tag or to identify better. The classification was improved by using only these 6 emotions with their 4 levels each one.
Thank you. Delia asks, so this resource was based on the Ekman model?
No. And I forgot to answer the second question of Delia, sorry, about if we analyze the difference in terms of emotion for each Spanish variant. I think the size of the resource is not large enough to perform this kind of analysis, but it's a very interesting issue. So maybe in the future we would do something like that, or maybe with Delia we can combine and try to propose something like that. And for the last question that was based on Ekman, no, it's based on a different model, which is called Shaver's model, like razor, like shaving. So this model from Shaver has the particularity that has 3 different levels of emotions. So we tagged a set of tweets with the 3rd level of emotion, which is like highly detailed, and then it's like a tree because it groups different subsets of emotions, and finally we go to the 1st level of emotions, and then we are getting like it's more robust because we have more detail here that we are trying to cluster in order to have a better tagging of emotions. More details of this is also given in the previous article. I think it's interesting to have a different way of tagging emotions, different to the Ekman system.
Thank you. Daniel Perez asks whether it is possible to try a model which mixes the 2 types of feature embeddings plus emotion levels.
Definitely yes, and probably results can improve by using a model like this one. So yes, actually this is future work. If Daniel wants to help us as well, welcome.
Great. Sarah Basharati asks, how did you determine the features? Was it in automatic task?
No, actually we built different sets of features one set was only the word space model, the one hot representation. Another one was combining this information with the emotion tags, and finally using only the emotion tags. And a little bit regarding the previous question on the particularities of emotion tagging of different variants, I forgot to say that an interesting result is that when we are not using words, but only the emotional tags, we are more able to generalize by using different corpora to tag another variant of Spanish. Then it seems that they allow us to better generalize irony for this task.
Thank you. And Delia replies, thank you. I was working on the role of effective information with irony detection.
Yes,
I think you should collaborate with Delia.
Actually, yes, because yesterday I was able to see her presentation, and also I was very delighted to see her work. I enjoyed it very much.
Great. Any more questions? Delia says thank you and smiles. Antonio says thank you. Interesting work. By the way, I had a question. How did you remove multi-word names in preprocessing?
We used a normal separator. We didn't perform any R recognition. So, for example, United States of America, it's United, and States and America. So of course there is emotion in the whole tag, but we are not considering it yet.
Yeah, but I mean, how? How did you know that it's a name?
No, we didn't. We didn't. We just separated each of the words composing the whole name. Or you mean that by capitalization?
How did you know that United States of America makes just one long name?
Oh, no, we didn't. We didn't perform that.
Yeah, you said it on the slide, which we did not see the numbers, but it was at minus 730. Anyway, okay, so you did not. Hamed asks, can this work help us in automatic irony interpretation?
Interpretation, well, yes, like slightly, not directly, because first, if you want to interpret something, you need to identify it. On interpretation, maybe we need a deeper study on what are the different variants of irony in different variants of language. Because what is maybe funny or ironic on one variant is not only because of the way of writing or style, but also because of the culture. And there are a lot of entities mentioned. Probably they have been identified, but maybe in this moment I didn't remember how they were identified. But yes, because it's a very important part of the work to know what is the attitude regarding these entities. So if we would like to have an interpretation, we must study this. So yes, it might help, but like in a very beginning part for this interpretation.
Thank you. There are more questions. The next presentation is also yours, right?
Yes.
Yes. Do you want to answer more questions, or we pass to the next presentation?
Maybe just there are a couple more questions, so if everyone is okay, let's proceed.
Okay. So Daniel Perez asks, regarding emotional levels, did you detect some of these features had more predicting strength than others?
Yes, definitely. The good part of the approach we followed is that we can know exactly which words are associated to some levels of emotion. So yes, and well, maybe even in the paper that I mentioned before, there is not a list an explicit list, but we can produce it. We can have it in case it's needed for other purposes.
Thank you. I guess from social networks, we already had the questions here. Please, host or who is monitoring the social networks, any questions from social networks? Yes, please.
Yes, there's a question. How do you think classifier took into account reversed balancing, meaning commonly present in ironic situations?
So it's referring to the unbalance in this task, particularly, if I understand correctly. Well, the imbalance problem was...
Ivan, you probably can copy the questions to chat.
Yes, actually, this is a very big problem. Actually, we started working on this from the task corpus that you may already know. It's a corpus already made that has some sentiment analysis, which is only positive, negative, and neutral, and known. And the problem with this corpus is that it's very highly unbalanced. So training a classifier is very painful because of this, and it's very difficult to obtain a decent average F-score. Then we started going deeper on this and started developing an emotion classifier for which we needed to manually tag these tweets. And perhaps the question comes from the side that there are emotions that are much more present in the Twitter corpus we collected, because most people is talking of anger or sad things instead of happy or love things, which are some of the tags we are using. So we used two different corpora. One of them was trying to force the balance of this corpus. Like if I have enough hate tweets, then I stop collecting them, start filtering them, and then I'm looking for the loving and happy tweets, which was difficult to collect anyway. But we forced this balance to train classifiers, and at the end we found that this improvement was not really helping us to have better tagging of emotions. So at the end we ended up taking like reality as it is. So there are more tweets regarding negative emotions, and of course there is a bias on that way. I don't know if that was exactly the question.
Thank you. Yvonne, any more questions from social networks?
There are no more questions.
Thank you. So let's pass to the next presentation. I guess you... no.
Your microphone is closed. It's closed still. Ah, yes. But the microphone is closed. Okay.
Okay. So thank you for your presentation. We will send you this diploma.
The audio is gone. Sorry.
And let's quickly pass to the next one.
Okay.
We will send you this diploma.
Yes, thank you very much, because now we are on time, over time. So the next talk.
Hello, everyone.
Oh.
I'm going to present this work.
Well, that will be our colleague, Consuelo Varinia Garcia Mendoza. It's her voice, and I will project this video.
Entitled. Hello, everyone. I'm going to present this work entitled Ownership Link Retrieval Between Documents. First, I will give a brief introduction. Then our proposal will be explained. After that, I'm going to describe the experiments and obtain results. And finally, I'll show the conclusions, and future work. An important goal for competition linguistics is attributing the authorship of a text and thus reduce the plagiarism, which is virtually impossible to manually solve due to the large amount of documents that already exist in the large amount of time it takes for a person to perform this task. For this purpose, there are techniques for analyze style and models of similarity in text. Journalism and law are areas where knowing the author of a document may involve saving a life. With the advance of research in technology, and particularly on computational linguistics, now a computer can simulate some human linguistic ability, as well as how to identify writing styles, thanks to the natural language processing, which provide techniques for implementation of tools that help. For this particular case, it is possible to try to associate a text with its respective authors. In this work, we present a tool that helps the analysis of text to group them according to their potential author. Attributing authorship is a problem in which there is a set of authors together with samples of text graded by them. When a set of samples is analyzed, a model is built on the grading style of each of the authors. Then the challenge is to identify the author of the text whose author is unknown by comparing the grading style present in the anonymous text and the styles of the authors who belongs to the set. Attribution of close authorship is when the author of the anonymous text belongs to the available set of authors. On the contrary, when the author does not belong or is not part of the authors within the set, it is called attribution of open authorship. Author clustering is a task in which, within a collection of documents of text, the main objective is to group documents written by the same author so that each group can correspond to different authors. This task can also be seen as the establishment of authorship links between documents. Authorship attribution is used to group each of the documents with their respective authors. PAN is a series of scientific events and shared tasks on forensic text and digital text stilometry, fostering forensic investigation of digital text by organizing shared task evaluations. CLEF stands for Conference and Lab of the Evaluation Forum and is a self-organized body whose main mission is to promote research, innovation, and the development of information access systems. Each year, a series of the new tasks are published with seek to be resolved among the research community, including social media and education, and share the solution. We evaluate our method on the author clustering task of PAN-CLEF 2017. Here we are some works related to style analysis and author clustering. Research at the National University of San Luis in Argentina performed intrinsic plagiarism detection based on global histogram by analyzing an author writing styles and identify style change in the histogram. Mexican research won the PAN-CLEF 2017 contest, presenting a award that grouped authors and classified authorship by performing a grouping analysis of characteristics and using the log entropy and TF-IDF models. In the same context, another work was presented, which grouped authors by means of a simple similarity measures that works with the probability distribution of the sequence of characteristics on the document. Another work participating in the context proposes methods for the task of identify the author, dividing into grouping of authors and detection of stale gaps. Clustering based on locally sensitive hashing the vectors of real values is used, which are mixtures with stoichiometry characteristic and back on n-grams, and a statistical approach based on some different TF-AD characteristics and characterize the documents by applying the Wilson's signal rank test to these characteristics. Style inference are determined. Performance in PanClef 2017 is measured through D-cube, F, V-cube, recall, and B-cube precision. A summary of scores can be seen in Table 1. The figures show the general architecture of the document authoring link retrieval model. The left circle shows the document grouped together and the inputs to the model. The style analysis and similarity measures boxes indicate the methodology that the model follows in order to group the input documents. The circle on the right represents the output of the model and contains documents grouped by model according to the similarities between them. In order to be able to compare two different documents, we use doc2vec. Doc2vec is a form of neuronal embeddings associated with a group of words. In this model, the content of the files is read and is assigned to the vector representation. However, in order to do this, text must be processed first. Then, with the help of doc2vec, vectors are generated as characteristic for each of the documents. After the text has been normalized, each document is given an identifier and added them to a list. The list of target documents was entered into doc2vec. In this way, a training vector model was generated with the documents. The text preprocessing stage consists of several functions of processing text containing the document prior to use doc2vec. The following functions are used: stop word deletion, low case conversion, each token is transformed into the low case letter, and limitation, each token is converted into its representative stem. The doc2vec parameters for generation of the vector are by default to exception of window, min count, workers, and debug words, whose values can be seen in the table 2. The grouping of the vectors obtained in the training was done with the K-means and hierarchical agglomerative clustering algorithms, which are some of the most commonly used clustering methods. These algorithms determine the number of clusters to which each document belongs. We experiment with all parameters cluster algorithm to train to doc2vec vector dimension clustering algorithm. Range of the clusters were from 1 to 7 parameters for doc2vec, where DVO, W, or DM, and test dimensions were 200, 300, and 500. Clustering methods were K-means and AAC, and the best results obtained with the training corpus and the text corpus of the PANCLEF 70 are shown in table 3 and 4. These results are the average of the evaluation provided by the PANCLEF 70 automatic evaluator. The training results are shown in table 3 and the test results in table 4. In both cases, the language cluster numbers, doc-to-vec algorithm, vector length, clustering algorithm, and the results of F1 score, recall, and accuracy metrics are given. Regarding the results obtained in the experiments of this model, we can observe that some of them are similar to those obtained by the first place of the participants. Although not excelling in the first place for all languages according to evaluation measures, EQF, recall, and precision, some of the obtained results can be comparable and positioned in the position of the context as a result of the proposed task among the first 3 places. One of the main problems we identify is the preprocessing of the text before the generation of vectors, as well as similarity measures for clustering. An important point to notice is that each language uses a different configuration and a different number of clusters obtained experimentally. When the text is preprocessed, we are able to obtain better results. This is because the method only needs to work with the words that give context and meaning to the text, allowing the construction of further distributed vector in vector space. With regard to the ways of generating vectors, there is not a very noticeable difference between DM and DBOW. The same goes for the K-means and HAC grouping algorithms. Models that work with words to create their feature vectors do not heavily rely on the modification of the parameter for creating vectors. That is, there is no significant improvement if the parameter values, such as dimension of the vector, are changed. What is more important are the texts that are used for obtaining the vector representation. This can represent a significant improvement in the grouping of authors. As a future works, we plan to experiment with different sources for generating vector representation. Thank you very much.
Yes. So, are there any questions?
We don't quite hear you. Don't hear you.
Is there any question?
Okay, then we'll a comment from Eliana Gomez. Very interesting. Not really a question. A question from Ahmed. Thank you. Was K-means the only method used for clustering the text?
No, there were two different methods for clustering. One was K-means and the other hierarchical agglomerative clustering, and not combined, just one or the other. So in the results, we have that sometimes we obtain better performance by using only K-means, and in other cases by using hierarchical agglomerative clustering.
you. Elena asks, did you try another document vector algorithm representation, or do you plan to use another one? And what kind of documents did you train?
We used pre-trained doc2vec. We didn't train it, and we were surprised to obtain these results. Actually, we think that it's possible to obtain better results with different corpora for training it, and also for different document vector representations. But for this work, we didn't try it. What we did is to experiment with different doc2vec representation. One of them was DM, and the other one was document bag of words. And the same that with grouping, in some cases we have better results with DM, and in others better results with bag of words. So in the end, we are presenting just the best results obtained with different combinations. However, it would be very interesting to have a way of establishing a recommendation taking into account the characteristics of the corpus. Because this is just like experimenting with one and other, and well, yes, the results are good, but there is not yet, or we would like to aim for a methodology for selecting these parameters before seeing the actual data.
Thank you, Elena. Continue the conversation. Yes, very high results. When I got in this corpus, I did so many experiments, and it is a really difficult problem.
Yes, I agree with that, because for this work, the thesis has like 20 pages only presenting the different results and different variants. So at the end, we just obtained the best combinations, and these are the ones we have presented here.
Kenneth asks, are the results of this work better than the supervised methods used before? I mean, in comparison with the supervised methods.
Well, actually, this task is of auto clustering without knowing the right answer. Well, for comparison, yes, but as a clustering task, we don't. I cannot see very well how to orient it in a supervised mode. So maybe this algorithm should be tested in a supervised setting to answer that question.
Antonio asks, have you known about the number of clusters previously, or how did you define the hyperparameter K, the K-means algorithm?
Yes, also a very good question, because as I said before, one of the parameters we were testing was also the number of clusters in both cases, for K-means and for hierarchical agglomerative clustering. So yes, you can see in the table results. Let me share it quickly. I think we are just on time. Well, but very quickly, just don't despair, because now I am not in time. So you can see this table, hopefully, and you can see here that clusters are changing 4, 6, 6, and also 4, 5, 4, 5, 5. But we tested with a range of clusters. It's kind of a grid search, we could say. So that's it. Thank you.
Thank you. I think we should pass to the next presentation. I will show you your diploma. This is your this is your diploma. We will send it to you. Thank you. Antonio also comments. Thank you. Good work. Yes, it's very true.
Thank you very much, and thank you for all the people who asked questions, and thank you for Elena for being here, that she was one of the experts on this field, so maybe we can try different solutions together in the future. Thank you, all of you.
Thank you, and I might also say thank you, and let's ask the last presentation, and then also say thank you. So we should restrict some time. At 6, we should finish because the closing ceremony will start. So let's pass to the next presentation. It's now the next presentation is by Luis and Mireia. Are you here? Luis, Mireia, are you here? Okay. Luis, please, can you share your screen?
Okay, here I am. Thank you. I will share my screen.
Yes, we have, okay, 23 minutes. Let's start.
Yes, I'm ready. So I will share my screen. Okay. Hello, everybody. This is the presentation of the ontological model to represent information about songs. The authors, Lizael Mendez Sanchez and Mireia Tobar Vidal. We are from Masters of Computer Science. The content for this presentation is a brief introduction, the ontology design methodology, the design, the results, the conclusions, and the reference used. So as introduction, an ontology defines a hierarchy of concepts, relationships, restrictions, axioms, and instances to describe a domain which will serve to information exchange. With the realization of this work, it is proposed to carry out an ontology implementation that shows that information related to songs which we can find today in our daily life. The objective to be covered is to provide a songs library to the general public, that is, to make inference information corresponding to the songs according to their musical likes, and thus make inquiries about the song's data. Which ontology design methodology I used? It was decided to use the Gruninger and Fox methodology since the domain of songs is very extensive. It is necessary to have the description of the scenario to know all the data that will be used regarding the songs. This methodology proposes to identify main scenarios, that is, the possible applications in which the ontology will be used. Then, it is proposed to ask a series of questions called competence, which are used to determine the scope of the ontology. These questions and their answers are used to extract the main concepts and their properties, relationships, and formal axioms of the ontology. Which are the steps of this methodology? First of all, we need to identify the main scenarios, then prepare competition questions, then make a description of classes, define the properties of the classes, that is, the data type properties and relationships between classes. And finally, the formalization of the competition questions. Just as this methodology says, we have here a sample of competence questions. We have more, but for this presentation, we only show 5 of them. What are the characteristics of a song? What are the songs lasting more than 4 minutes? What are the registered music genres? What are the registered singers or songwriters named with Mexican nationality? Who are the members from the rock band called Queen? So now we define the classes in the ontological model. Here we have just a sample from the main classes and its description. We have the song, that is the main class containing the different data to be provided about the song. The band, that is the class corresponding to the song interpreters, in this case, a group of singers. Singer-songwriter is a subclass of person and corresponds to the song interpreters. In this case, it is the responsible person for composing and interpreting the song. The composer, that is also a subclass of person, and it corresponds to the song or song's composer. A composer can be a singer-songwriter too. Is producer, also subclass of person, refers to the song or the album producer. The same way, it can be a singer or a singer-songwriter. And then the music genre. Class lists the different genres of music that exist and relate them to each song. We have more classes, but we have this sample for this presentation and to show how it works. Now, as well as a sample of the classes, we have a sample of data types, properties, and the domain each data type property has. Then the range or the data type we can have. For instance, has title, the domain is the song, the range is a string. Another data, we can have the duration, it is related to song, and it has also a range of decimal number. And then we can list another domains for different data types, properties, and its range. Now the object type, properties, or relationships between classes. Each class has a relationship with another class and so on. Here are a sample of that kind of relationship. For instance, a song belongs to a music genre. A song, it is included in an album. It is interpreted by a singer or a singer-songwriter or even a band. And we can have a single singer or even a band that is a group of singers, maybe. And it is composed by, is recorded by, and is produced by. It is everything related to song. Then we have the relationships, for instance, for band, for singer, songwriter, for composer, and for producer. For the design of the proposed ontology, we used a Protege tool. That is an open source software to build ontologies through its interface that helps the developer in the process. Here we can see a hierarchy showing the classes, the main classes, and the subclasses. For instance, we can see a person class and a singer, songwriter, the single singer, the composer, and the producer are subclasses of person, and so on. Now, related to the previous slide, the number 9, we can see the relations between the ontological model classes. This is how Protege tool show us the relations between classes in different ways, different colors and showing the range of each domain. Also here in Protege tool, we can make a class restriction singer-songwriter. For instance, we have this, the singer-songwriter. It is equivalent to composer of, or maybe a singer, and it is a subclass of person. In this tool, we make these arrangements and we can design our ontology in a better way. Another sample is the class producer that is equivalent to singer or singer-writer, and it is a subclass of person. And finally, we have the results. This ontology evaluation was carried out at the application level, that is, through the answers provided by the ontological system. The same way, these answers are provided when formalizing the competence questions. The ontology meets the consistency criteria, and the Hermit reasoner was used to test the ontological model from the Protege tool. For the realization of the queries, a proper language is used for ontologies, which is Sparkle. Now, a sample of the formalization of some competition questions. For instance, number 1, what are the characteristics of a song? Then we have here the Sparkle query. And for the number 2, what are the songs lasting more than 4 minutes? And here we have the code for this Sparkle query. Now we will see the results for these queries. The number 1 shows us a list from the preloaded data we have, showing the result from and the answer for the question 1. And this is the result of the question 2. It is important to say that we need a big amount of preloaded data to have good answers about any questions we make to this system. And finally, the conclusions we have. The main contribution of this work is the application of a methodology that is Gröninger and Fox for an ontology manual creation applied to the songs domain for research information related to them, that is, specific songs data people want to know, in order that different types of users can consult these records when they need to know a song's characteristic data, its album, interpreters, related record companies, composers, producers, genres of music, and musical instruments that interpreters use. The methodology used has been of great help to solve the problems corresponding to structure, organization, and information management through the use of semantic web tools such as ontologies. The use of Protege tool to carry out design of the ontology in combination with the Sparkle query language has been used to answer the competence questions that were posed in this work, in addition to carrying out the necessary queries within the ontological model to gather the required information. Here are the references we use in this work, in this paper, and that is all. So if you have questions, please feel free to ask. Thank you.
Thank you. Raise questions. Comment, you always ask questions. Maybe I didn't quite understand how large data set you have for this ontology.
Sorry, I didn't hear well your question. Can you please?
How large a data set do you have to which you apply this intelligence?
Oh yeah, we have around 200 records to data set this work.
200. Daniel Perez asks, which database did you use to test the ontology? That's more or less
Actually, we didn't use a database. We only use the ontology, the web semantic tools and SAML, XML to store the data and then query about it.
Thank you. Hamad asks, do you use any kind of language understanding technique to interpret the question?
No, we didn't use any techniques of language understanding. We only use the technology of web semantic and not understanding techniques.
Thank you. Elena asks, very interesting work. Is the ontology created freely available?
And not at this time, but maybe for future work, we will publish some of these works and data sets, maybe to use for another research.
Thank you. Jason asks, how is this ontology compared with popular knowledge bases such as Wikipedia or Music Brains?
Oh, that is because we don't know what does Wikidata data Music Brains use. This is just an alternative, another way to store data and make inference about the data we have. The use of ontologies give us a different way and maybe an alternative for some future works using web semantic tools.
Jason continues his questions. What are some specific cases for this kind of ontologies, either from music industry or from end users, listeners?
I think it is more specific for final users, but it could work for either music industry or final users to know. The goal of this paper, of this work, is to provide this alternative tool, another way, not only using the normal databases we use daily, but instead using web semantic tools.
Thank you. Yvonne, any questions from social networks?
There are no questions.
No more questions. Okay, Hamad, thank you. I guess other people will also thank you. So now I will show you the diploma now. Moment, let's share screen and here we go. We will send you this diploma. Thank you very much for your presentation. Now, after this session, we have several minutes, still 5 minutes. After this presentation, there will be the closing ceremony. Please, all of you attend the closing ceremony in 5 minutes. If you want to discuss something, if the presenters or the public wants to present, microphone. Curator, if you want to I see other people also say thank you all. Okay, anybody wants to add something? Not much. Iran. Okay, Iran came to our room. Iran, do you want to say something? Now your microphone is off. Your microphone is off. I have no idea how to enable microphones. But Iran surely wants to say something. I know. Okay, let's try now. Now you can. Can you?
Yes, now I can unmute myself. Oh, because I had to be in 2 rooms at the same time because there was a student of us, Ojo Olumide, presenting in the other room, and then one ear was listening to him and other ear was listening here. So I'm connected back with this.
Do you think next time it would be a better idea to hold only one parallel session? I mean, no parallel sessions, but then the conference will take a month.
Maybe now it's different because it has grown too much. Well, not too much as in badly, but now it has grown.
No, it has not grown. We always had like 4 or 5 parallel sessions. But the question is, when we physically travel to another place, we have to travel for 1 week, choose our parallel session, and return. Now we don't need to stay there.
Yes.
So we can hold the conference the whole year. And then if you choose one specific session, you can attend it.
Well,
there's no much reason to break the conference into 1 week.
I agree. If it's not physical, maybe it's a good idea to make it longer because there is no need to be physically in the same place. I have a suggestion, and it is that in this case, we had parallel session, but I would suggest not to mix the same subject. For example, these 2 parallel sessions were natural language processing at the same time. So I think that for most people, it was a difficult decision to be here or there because a lot of people is interested in NLP, so they have to split. I found some colleagues also that had to move from this talk to the other and vice versa. Maybe it would be not necessary if maybe vision, which maybe we are not so close to vision or robotics. I don't know. It would be better perhaps.
Yes, very good idea. Okay, I think now we can finish our session. Please, all of you, attend the closing ceremony in 1 minute. I guess it is in the program. Now, how do we close the session? I think host can do it.
See you there.
Thank you very much. And see you in 1 minute at the closing ceremony.
Thank you to the chairs as well for this hard work.